Today, I have two improper integrals for you guys. And notice that how similar they look, right? For the first one here, we have an x. But for the second one, we have a square root of x. Of course, you should pause the video, think about how to do them first before you watch the solution. Ready? Okay, let's go. For the first one, notice that I have x here and x here. I would like to factor out the x first before I do substitution. So this will give us 1 to infinity and 1 over x times 1 plus square root of x dx. And then I will do u equal square root of x. Let me square both sides and then take the derivative. So dx is equal to 2u du. Now remember, these right here are the x values. To go to the u world, also change the numbers. Plugging 1 into here, square root of 1 is 1. Plugging infinity to here, we get u is infinity. 1 over x is u squared. 1 plus square root is u. And then this is 2u du. And now we can see one of the u's get cancelled. That's pretty much it. In fact, later we have to do partial fractions. Not so bad though, but let me just write it down better for you guys. 2 over u times 1 plus u. Okay, to integrate this, we will have to have something over u plus something else over 1 plus u. To do this, we can do the cover method. To figure this out, we go back to the original, cover the same denominator, and ask yourself, how can we make u 0? U has to be 0. But you put 0 into this u. So 2 over 1 plus 0 is just 2. Secondly, for this number, cover the same denominator from the original. How can we make 1 plus u 0? U has to be negative 1. Put it here. 2 over negative 1, we have negative 2. Now we're ready to integrate them. This right here, we get 2 ln u and then minus 2 ln 1 plus u. Notice I don't need the absolute value because we are going from 1 to infinity. The input will always be positive anyway, so it doesn't matter. Now, before we plug in the numbers, I'm going to just factor out the two and combine the natural logs together. So when we do this, 2 in the front, ln u minus ln of 1 plus u is ln of u over 1 plus u. And then we plug in 1 to infinity. When we plug in infinity to here, technically we will have to take the limit. But if you look at the limit inside out, u over u is just 1. Right? The plus 1 doesn't matter. ln 1 is 0. So when we plug in infinity to here, the first part will be 0. Minus the second part, plugging 1, we will have 2 ln 1 over 2. That's pretty much it. And if you would like, you can actually turn this into 2 to the negative 1 power and then put the negative to the front. So altogether, we get positive 2 ln 2. So that will be the answer for it. Now, as of this one, I will still factor out the square root. You will see, it's not bad. 1 to infinity, 1 over square root, 1 plus x. But this time, what do we do though? In fact, I will still let u equal square root of x. Because this right here can be looked at as square root of x squared, which square root of x is the inner function as well. But if you just say, let's get rid of the square root by doing this, you will see it works out very nicely too. Do the same thing, x equals u squared, dx equals 2u du. Same idea, x equals this, x equals that, meaning we get u equals 1 to infinity. This time though, we have 1 over u times 1 plus, this is u squared. This is 2u du. Very similar, huh? And then u cancel. But now, do we do partial fractions? No, because when we integrate a number over 1 plus u squared, we will just get inverse tangent. This is just the integral from 1 to infinity. I can put a 2 to the front, and then we have 1 over 1 plus u squared. That will give us inverse tangent, which is a very different answer than this, right? Alright, and then we plug in infinity and plug in 1. Okay, 2 times inverse tangent of infinity. Let me just make a note here. When we have the limit as u going to infinity of inverse tangent, we get pi over 2. Alright, so the first part will give us 2 times pi over 2. And then minus, still have the 2. Plugging 1 in here, inverse tangent of 1. Think about the first answer, right? So tangent of that angle will give us 1, 45 degrees. But we are all adults now, so we say pi over 4. So this right here is pi over 4. So ladies and gentlemen, this right here is pi, this right here is pi over 2, pi minus pi over 2, we get pi over 2. Yep, that's it.